What's up guys, this is GhoUL, and in this video we are going to talk about how to create timers in C++. So I will tell you the whole thing which we are going to do in this video. First we'll talk about how to create timers, and then we'll talk about the basic problem with the timers which we are going to create, and at last I'm going to do some experiment. Okay, I actually thought of a method to fix this problem, and I'm not sure if it will work or not, but let's just try this. Okay, so guys, let's get started. First of all, you will need to include these packages. Okay, first is ctime, second is windows.h, and the next is std library. We are including std library because we want to use system cls command. I hope you know about that. If you don't know, please google it. Okay, it's system cls like this, and we are including windows.h because we want to use sleep command. We type it's like this. Okay, if you don't know about this, please google it, please read about it once. Otherwise, I'm also going to create a video talking about all of these exclusively, and then we are also including ctime because we need to use a function known as clocks. Guys, I recommend read about clock function or just watch the exclusive video I created for all three of these at once. So guys, let's get started. Okay, first of all, mm, I told you the basic things which you need to know before creating a timer. Okay, you need to know about these three functions. So let's get started. Int x equals to 0. Okay, this is the first integer I created, and to create a basic timer, very basic timer, all I'm going to do is x. No, not x 1. Okay, and uh, let's do this. Um, how about this? C out mm, time lapsed. Okay, this is a problem in here. It's like this: time elapsed, um, and then I print x, and then I sleep for 1,000 seconds. And remember, guys, sleep always starts with capital S. Many do that mistake. And next, what I'm going to do is system CLS, and at last x plus plus. And as you can see, the basic program. Uh, There you go, your program, your timer is ready. Okay, so let's just, okay, there you go, I caused the problem. Okay, let's just try running this again. So there you go, guys, this is your working timer. It works nice, okay, nicely. Okay, it says, okay, it actually looks like it's working very nicely, but there is a small problem with this. Okay, and the problem is, okay, the sleep command sleeps down the program for 1,000 seconds, 1,000 milliseconds. Okay, that is equals to 1 seconds. But the computer also takes its own time to uh, execute these statements. Okay, like system CLS, it takes time to clear the screen. It takes time to increase the value of x by 1. It takes time to print time elapsed equals to x, and it takes time to um, test this loop. Okay, it takes time for everything. So guys, there you go, this is the problem with this program. It actually takes more than 1 second, okay, to run this loop, more than 1 second to run the loop one time. Okay, so guys, what I thought of this, the solution to this problem was, I thought, let's create two loops. Okay, I thought of let's creating two loops. Okay, the first one will be the test loop. Okay, uh, so there you go, guys, this is how I'm going to create the test loop. Okay, the test loop is going to calculate the time lag. Okay, and in actual timer, in actual loop, I'm going to subtract that, actually I was sleeping for 1,000 milliseconds. That was 1 second. Okay, but I will calculate the time lag from the test loop, and I will decrease the time sleep time in the actual loop. That's what I thought about. Okay, so to create a test loop, I will need to add three more variables. Okay, two more variables into y equals to 0 and into z equals to 0. Now let's do this. Okay, while x less than equals to 10, and then what? um let's do this. If I will calculate the time in the last loop. Okay, so I'm going to do this. If x equals to 10, this will be the last loop. Okay, if x equals to 10, it's going to be the last loop. So I'm going to do this. Y equals to clock. So now y is going to be assigned a value, the clock, the timer in here. Okay, and then next what I'm going to do is see out. I'm going to create the same, I'm going to write the same statements that I will write in my actual loop, so as to get the perfect time, the perfect, the closest time to what this computer, to what this laptop is actually going to take to calculate, uh, to run all of this. Okay, to run all of these statements, that I will actually use in my loop, in the real loop, in the real timer loop. So that's why I'm actually using all of this in here. Elapsed time, and that will be equal to x, and then sleep for 1,000, and then system cls, sorry, and then x plus plus. So guys, there you go. uh, this is the test loop. Okay, and let's just reduce the time to 1. Okay, I'm not interested in wasting too much time. So what's going to happen is, guys, when x equals to 1, what will going to be happen, this will be the last time this loop will run. Okay, the y is going to be assigned a clock value now. Okay, and then what's going to happen, this is the program is going to execute these four commands. Okay, like it does normally, and it's going to test this, and it will see that x not equals to 0, so test will fail and it will jump out. So it will actually do all the five things it was actually doing in my real loop. In my real loop, it was doing all of this. First of all, it was printing this, and then it was sleeping for 1,000 milliseconds, and then this command was also over there, system cls, and then x value was being increased by 1, and then it was testing. So more or less, it should give us the basic idea of the time lag. It should give the computer the idea. So what I'm going to do is y equals to y minus clock. So there you go, guys. And next, since this function, sorry, not it won't be y minus clock, it will be clock minus y, clock minus y, and this is going to give me the time, the clock actually take, the timer actually took to run from here to go to here and to test and to jump to here and subtract this. So I will get the rough estimated idea. Okay. Mm, let's just actually test this, how much time it actually takes to run this. It doesn't it You will see that it actually was not really taking 1 second, it was taking more than 1 second. It will take around 20 milliseconds more. It will take around 1018, 19, or 20 milliseconds in total. Let's see. Oops. I think this is an extra over here. Okay, let's try this now. um I think there's, okay, I did this mistake. What the hell did I do? Why the hell did I do this? Why the hell did I do this really? And as you can see, okay, let's do this now. Okay, what the hell am I doing? You I'm so sorry about this very, very, very serious mistake I did. That was not expected. And as you can see, it actually took more than 1 second. It took about 1018 milliseconds as I expected. So in every 1000 seconds it will be losing about 18 milliseconds, and every 3000 seconds it will be losing about 54 seconds, and every 1 hour it will be losing more than 1 minute. And I don't want my clock to go 1 hour slow in uh, um, for every 1 minute. I don't really want that. Okay, so this is not really nice. Reduce this to minimum, to reduce this to minimum, what I'm going to do is, mm, as you saw guys, first of all, let's put this system CLS above 1000. Okay, this way we won't be able to see that time time remaining elapsed time equals to 0 1, which we are seeing right now. As you can see, it won't be visible because since we have put system CLS before. As you can see, it's not visible now. So guys, as you can see, we have the time it requires in one loop. Okay, so what I'm going to do is y equals to y minus 1000. So this is going to give me the time lag. Okay, and now I'm going to create my real loop. Okay, and to create my real loop, let's just copy this, control plus C, control plus V, and I'm going to show you guys something. Okay, I'm going to show this to you if this works or not. Okay, and you will see that this actually is working very nicely. That's what I think it should work. So let's do this again. Z equals to, no, I'm going to subtract the time lag as I told. Okay, 1000 minus y, and Z equals to clock minus Z, C out, Z. And as you will see, the time lag is going to be reduced very considerably now this time. I'm so sorry about what just happened. I will need to check the code one more time. Okay, so the problem is x wasn't equals to 0. First I will need to do x equals to 0 once again in here, or maybe x equals to 1 will work fine too, because in that case it was increased. So this should work very perfectly fine. As you can see, it actually took lesser time. Okay, it actually, the time lag has been reduced very much. Earlier it was 20 milliseconds, and since I tested this, I'm only testing this, it has actually reduced but uh, it has reduced by 1/3. Okay, the time lag has been reduced by 1/3 approximately. Let's try running this one more time, and as you can see, the time lag has been reduced to just 2 milliseconds this time. From last time it was 1118, and this time it only 1102 milliseconds. So the time lag has been reduced considerably. It will only lose 6 seconds in an hour, approximately 6 to 7 seconds in an hour. And it has been reduced again. So there you go guys. This way, I won't say that it's the most effective way to um, do this or to create a timer, but this is a very nice way if you want to reduce the time lag, and that's what I think it is. So to create a timer, all I need to do is, as you can guess, I already have the time lag, and I don't need these stupid commands anymore here. I was just testing, so this is going to work fine. The timer is ready. As you can see, the timer is going to work perfectly fine now. Okay, to fix this, all I need to do is copy control plus C from this from here, and do this over here, because I don't want my the whatever is getting printed to be erased immediately, and the command to sleep for 1000 minus 5 milliseconds. First I want it to be to be there and get stay printed for 1000 milliseconds and then to be erased. That's why. Let's try this again. And there you go, guys, your timer is now ready, and this is a very very nice working timer. This is very close to actual timer. Okay, it's not going to give you more time lag than 10 seconds in an hour. The previous timer was giving you a time lag of 1 minute in an hour. So I really think that it's a very effective way to create a timer. First you create a test loop and then calculate the time lag and create another loop to and reduce the sleep time in the next loop. Okay, by reducing 1000 by 1000 milliseconds by that time lag which you calculated from your test loop. So thank you for watching my video. I hope you liked, and please don't forget to subscribe and share. And if you have a better way to create a timer, please do share. Please uh, tell me in the comment, can tell me through comments or mail me, uh, but please do tell me and I will make a video for that. Okay, so thank you for watching the video once again, and please don't forget to like, subscribe and share, guys. And I really hope you like this new method which I thought of.